Everyone, welcome back to our fifth part of our prediction market smart contract project. And in the previous parts, we created this function transfer ownership, set platform fees and withdraw fees, claim refunds, and so on. So in this part, we are going to add view and public functionalities in our smart contracts. And this is our last part of our smart contracts. Then we will jump on to testing and deployment. I will show you some of the best test practices and fuzzing, and then we will deploy this prediction market smart contract on chain. So let's get started. Let's first start with our first uh, public function, calculate payout. I think uh, this one, the function I previous parts in I mentioned, we will create this function in the upcoming parts. So let's create this function calculate payout. And we have to take three parameters here. One is market ID, and event 256 bet amount, and a boolean of predicted outcome. So let's declare predicted outcome. Now let's make it public view, and it is going to return us u into 256. So let's returns. Now let's take market storage. Market is equal to markets, and we need to pass market ID here. Then let's take another variable u in 256 total pool is equal to market dot total s bets plus market dot total no bets. And now let's take another variable here, local variable u in 256 winning pool is equal to predicted outcome. We need to take this predicted outcome. If not this, market dot total yes bets, otherwise else market dot total no bets. Nice. Now let's check here again. If winning pool is equal to 0, then we need to return 0. And now let's return bet amount plus, not plus, actually we have to multiply this, multiply total pool, and we have to winning pool winning. There we go. Let's format this, and now let's go ahead and create again another function for get market. This is very small function. So function get market, u in 256. Let's take a variable as the parameter u in 256 market id. Let's make it small and let's make it public. Not public, actually we have to make it external, and view, and we have to make it market exist. Inside that, pass the market id function modifier, and we need to returns bait, the array of baits, and we need to make it inside the memory. And we need to return market baits and pass the market id. There we go. This is a linter error from VS Code. Now let's go ahead and create next function, get user bits in market. So we have to use loop there. So let's create function get user bits in market, and we have to take two parameters, address of the user and u 256 market id. Let's make it external view, and it will return the same. So let's copy this from here, paste it here, and go down. Let's take a bait, the array of bait, and let's take it inside the memory, and let's name it, let's say all baits is equal to market baits, and inside that we have to pass market id. Now let's take another variable u in 256, let's say user bait counts is equal to 0. Then go down and let's take for u int 256 I is equal to 0. I is less than all baits dot length, and then I plus plus. Now let's take if all baits, copy this from here, all baits, if all baits, you need to pass I here, dot better is equal to 0, not triple, it's single, equal to 0. Then you need to pass user baits count plus plus. That's it, that's our for loop. And again let's go down outside this for loop. We need to create bait, let's take it inside the memory, and user baits is equal to new bait, and here we need to pass user count Let's take another variable uint 256. Current index is equal to 0. And now go down and let's run again another loop for let's say uint 256 I is equal to 0, I is less than all bits dot length, then I plus plus. Now let's check if all bits dot not dot, we need to pass an I here, and dot better is equal to user, then user bits, then current index is equal to all bits, and we need to pass I inside there. Let's go down, and current index is plus plus. That's it. So, and now also we need to return user bits from here. That's it. There we go. This is again VS Code error. Calculated payout, payout. Inside calculated payout, which is this function claim winnings. These are some VS Code errors. We will fix this later. So let's go down and let's create our next function, and this is our last function, and after that we will fix the errors, and we will start with texting. So let's write our last function here, function get market odds, and we are taking here uint 256 market ID. Here let's make it external view, and market exist, and we are going to return from here returns uint 256 yes odds, and no odds. There we go. Markets, and inside that pass the market ID. There we go. And now let's take another variable uint 256 of total pool is equal to market dot total yes bits plus market dot total no bits. Now let's check here if total pool is equal to 0, pool is triple not triple double equal to 0, then we need to return. Let's directly return here, let's say 5000 plus 5000, not plus. Now yes, odds is equal to market dot total yes bets. Let's multiply this by 10,000 and let's divide this total pool by total pool, and same with no odds. So let's copy this from here and let's name it no odds market dot total no bets multiply 10,000 and total pool. So with that our smart contract is almost ready. Let's try compiling this and we will fix this error. Forge build. So we got the error here, line number 2020, sorry, 224, 224. Let's go here, 224 count come. Now let's try building again. Calculate payout. Actually this function name we are calculated payout. It takes three parameters and we need to pass this here. There we go. I think which is this function claim winnings. Let's see. I think it is market dot outcome. There we go. Now let's try rebuilding. Now our contract is finally compiled successfully. You can see our compiler run with warnings. So some of the warnings here. So ignore this warning. So so far in our project we have this errors, we have this events, and we have some of the we have this declared this enum, then struct, then we have bed struct, we declare these four variables, then mapping, we have three modifiers here. So you can see I will also give you the git source code of this project. We have constructor, we have create market function here which is the external, then we have place bet function here, then we have lock market function here, then we have resolve market function here, then we have claim winnings function here, then we have cancel market, then we have claim refund function here, then withdraw fees here, and set platform fees, transfer ownership function here, calculated payout function here, then we have get market function here, then user bets in market function here, and at the last we have get market odds here. So far we build these smart contracts and we compiled it successfully. In the upcoming videos we are going to test. I will show you some of the best test practices, and then we will deploy it on base Ethereum Sepolia chain. So with that I am closing this part of this prediction market smart contracts series, and I will see you in the next one.